Greetings, scholars, and welcome back to another Algebra 2 video. We're still recording from the classroom, so hopefully the echo is not that bad. This is going to be for lesson 1.3, which is about domain and range of functions. And this lesson is really more about how to write the domain and range of a function based on what kind of function you're looking at and how that function is given to you. So we're just going to start with the basic vocab of domain and range. We already talked about this in 1.1. The domain of a function is the set of all possible values that x can take, and the range is the set of all possible values that y can take. Now, depending on how you're looking at the function, or another way to think of it is that some functions will lend themselves better to different types of expression. So we're going to focus on two of those forms, and then if you're interested in learning the third, I can show you what that is like, but that will not be done in class because you don't really use that until much later. So we're going to talk about expressing the domain and range as a list of values, and then we're going to talk about an interval of values. So I'm actually going to use some stuff that we're going to see in class. You'll have the opportunity to redo it. And I just want to start you off with this first one. So here you're given a function as a set of points. We're focusing on number 1. Sorry about that. Somebody came to the door. So if I wanted to know the domain of the function in number 1, the way that I would express that domain is it's just going to be a list. So the shorthand for domain is capital D and then a little x here. And so our domain for this function is literally the set of all of the x values. So my x values for this function are 1, 2, 3, and 4. And I would list those values. And there's our domain. If I was to do the range of those values, it would be capital R subscript y. This is just the notation. And then we would do the set. So what are my y values? 5, 10, 15, and 19. And then that's it. So our domain for the function in number 1 would just be 1, 2, 3, 4. Our range would just be 5, 10, 15, 19. And that's all you have to do. You just list them. Using a list is really good if you have a set of points like you have in number 1, or if you have a table of values like you do in number 2. However, you run into a situation or you run into a problem when you look at something like this. When you have a graph, you have a serious problem. And that problem is, if I was to say, hey, what's the domain of this function? The question really is, well, what are the x values that this function can take? And you might say, oh, well, like -2 and -1 and 0 and 1 and 2. And those are correct, but they're not the only x values. In fact, every single number in here, every dot, every point is a coordinate pair. Now, just because the coordinates are not whole numbers or they're not integers, it doesn't mean they're not valid. So trying to list all of the x values in here is impossible. So what we do is we describe the interval. We say, well, the domain is all of the values between something and something. And I'm going to show you two ways to do this. So the first idea is that for our domain, the domain is the x's. So my lowest x value is at -2, and my highest x value is at +2. So one way that I can write this is that for my domain, let's go to a pen. I can say that -2 is less than or equal to x, which is less than or equal to +2. I'm creating a compound inequality, and if that sounds really complicated, just keep in mind all we're saying is that x is between -2 and 2. And it includes both of these numbers. You may have seen this in Algebra 1, where I'm going to pause. Hold on one. All right, apologies for that. People came in with questions, which is good. I'm here to help, but I also want to continue recording. So our domain here is between -2 and +2. So rather than me trying to list all these points, we just describe this interval. So x is greater than or equal to -2, and it is less than or equal to +2. You may have seen in Algebra 1, if you have like an open circle here, then that means it's not part of the function. You don't see that all that often, to be honest. What you will see in Algebra 2 is you will see interval notation. And essentially what it looks like is it's another way to represent a huge interval of numbers, but it looks different. So I'll show you what it looks like. So here, we're going to go into pen. We're going to go into pen. Right? And I'm going to explain what this is. So interval notation, what you do is you put the smallest number in the interval and then the largest number in the interval. So what we're saying is that the interval for the domain is between -2 and +2. And then if the lower number is included, we use a bracket on this side. So the bracket means that the value is part of the domain. So here, this is saying our domain is between -2 and +2, including those numbers. For the range, I'll show you both for this. So using an inequality, if we look at the range, the bottom value of our range is 0, and the top value of our range is 4. So we would say that y is less than or equal to 4 and greater than or equal to 0. Or y is between 0 and 4, including the 0 and the 4. And then again, if we are using this interval notation. So again, our lowest y value is 0, our highest y value is 4, and then these brackets mean that the numbers are included. Now that's pretty much it for this video. There is one other thing I want to kind of share out, and that is a situation like number 2 here, where we have arrows going down. So when you have arrows, the assumption is that the function keeps going infinitely in both of these directions. And so the way that we express that is by using infinity. So for this particular function, actually I want to use a different one. let's use that one. Why not? Because I feel like we're going to have a lot of questions on this. So our domain for this, if I'm using interval notation, this graph, even though it's hard to tell, it is going infinitely to the left and to the right. There are no x values that aren't covered. So literally, our whole domain is all real numbers. And we can actually say, hey, our domain is all real numbers. But if you look at the range, that's not the case. Because the ranges are y values, and we have a maximum y value, right? That maximum y value is 4. Now, there's no lower boundary here. So we could write our range as y is less than or equal to 4. Or using interval notation, between negative infinity and 4. Now you'll notice that I'm using parentheses here instead of a bracket. This parenthesis, I think is the singular. This means that this value is not included. And it's not included because negative infinity is not an actual number. It's just a concept. Whereas this bracket means that 4 is absolutely a part of the range. Another way to think about it is like this. If I asked you, what's the biggest number in the range? You could definitively tell me it's 4. But if I asked you what's the smallest number in the range, you can't give me one. Because any number that you give me, I could just take 1 away from that number. So there's no actual lower boundary on this range, and so we use parentheses. All right, that's going to be it for these video notes. It's really just about the notation. There is something else that we'll talk about in class. We'll go into more detail, but I want to leave you with this idea, is that when you have equations, your domain and range are almost always all real numbers. Like there's no restriction. But these are a couple of types of functions where there actually is a restriction, and we have to be careful about the domain and range. So think about what those restrictions might be. For some of them, it's for the domain. For others, it's for the range. For some, it might be both. So I will leave you with that thought. Enjoy the rest of your evening, and I'll see you tomorrow in class. Take care.